We're asked to find the force Q required to keep this system in equilibrium whenever an input force of 100 newtons is applied. So to solve this problem, we're going to find a force from B to D, and we're going to take the x component of that force, and that will give us a force applied to the right direction. And to keep the system in equilibrium, this applied force to the right needs to be equal to the force applied to Q. And we're going to be using the expression that the sum of moments about the point C is going to be equal to 0, since this machine is going to be in equilibrium. So for part A, it's asking us to use beta is equal to 0 degrees. And to start with, I'm going to first find unknowns in this free body diagram to help us solve for the moment. So we'll start by finding angle theta. This angle theta. So just to clarify, it's this angle right here. This angle theta. This angle theta. And that's going to be equal to the sine inverse. It's the sine inverse of 35 over 250. And that will give us an angle of 8.048 degrees. And next we're going to use the expression that sum of moments about point C is equal to 0. So when beta is equal to 0, this incline here is going to be flat. So we can say that the sum of moments is going to be equal to 100 times 350 minus the force F to BD times the sine of the angle we just calculated times 200 is equal to 0. And we solve for this unknown, this single unknown in the expression. And after doing so, we end up with a force BD that is equal to 1,250 newtons. And to solve for the force required to keep the system in equilibrium, we take the x component of this force. So the x component of that force, that's going to be equal to the force we just calculated times the cosine of the angle that we calculated. And that's going to give us the force of 1,237.69 newtons, which is also equal to our Q force. And next we'll do part B. So for part B, they ask us to use an angle beta, which is equal to 6 degrees. So beta is equal to 6 degrees. And now this free body diagram, it's no longer going to be a flat surface like when beta was equal to 0. It's now going to be an incline, just like in this free body diagram. So we're going to solve for some unknowns now that this incline is here. but we're still going to use the same steps to get our final answer. So we're going to find lengths from C to G, and we're going to find lengths from E to D. So to find our length from C to G, we can set this equal 200 times the cosine of the angle beta. And find the length from E to D, we can set this to 35 minus 200 times the sine of beta. And to solve for the angle theta, you can say that theta is equal to 35 minus 200 times the sine of 6 divided by 250. Should be the sine inverse. So the sine inverse of this expression. The sine inverse of this expression. And this will be equal to 3.232 degrees. And now we can use now we can say that the sum of moments about a point C is equal to 0. And we can solve for the force BD. So we can say that negative F of BD times the sine of 3.232 times 200 times the cosine of 6 minus F of BD times the cosine of 3.232 times 200 times the sine of 6 plus 100 times the cosine of 6 times 350 is equal to 0. And we can solve for this unknown F of BD. This F of BD. And solving for that F of BD, we get a force of 1084.91 newtons. Okay, so now we take this force we just calculated, and we find its x component. So to find the x component of that force, that's going to be equal to the force BD times the cosine of the angle 3.232, and this will give us a force of 1083.184 newtons, which will also be equal to the force of Q to keep the machine in equilibrium.